broad concepts, all under the umbrella of, stop trying to boil the ocean. From a security perspective, we get inundated with information, and too often we try to fix it all, or we're mandated to fix it all. And as new technologies come in, as new tools come in, as new compliance regulations come in, everything's geared toward, oh my God, you have to fix everything. It's not realistic, it's not reasonable. And when we try to do that, and when we try to measure ourselves against that, we're doomed to failure. So I'll be talking a little bit about that and hopefully highlighting a better way. My name is Seth Matheson. I am Tenable's Distinguished Security Engineer. That's a fancy title, which basically means that I go around the world and help customers with interesting problems. Whether it's I have a unique environment that nobody else has, or I think nobody else has, or I have an extremely complicated federated environment, or I just ran into Seth at a conference and picked his ear and I got his attention with something. So regardless, I see a lot of things, and my role really is to help customers succeed. All right, so looking at the modern attack surface, like I said, it's constantly growing. It's no longer you have a bunch of servers in a data center, you have maybe some laptops or some people with a desktop. Now we have cloud, we have operational technology, we have internet-facing things that get spun up all the time. Anybody with a credit card can go out and spin up stuff in Amazon or any other cloud. It's really hard to keep track of everything that we own, everything that we're responsible for, let alone have the right technology to assess it all properly and then figure out what to fix from all of those things. Technology is also becoming increasingly dynamic. Some of us still have mainframes. Some of us still have those really monolithic things that are going to sit in a data center and be on 24/7. It's as simple, it's a Windows patch. It's making sure you've got your long password so it can't be cracked, that sort of thing. But more and more we're leaning towards dynamic roles on giving access to people only when they need it and only exactly what they need. It's containers that live for a few seconds that do a very specific task and then die. How do we assess those for security? How do we make sure that all of these interbits that can talk together and must talk together for business purposes are secure in the way that they talk together? We're not giving them too many permissions. We're allowing what's needed, while at the same time, handling all of the legacy stuff that we have, because you can't just turn off that mainframe, right? It's got 47 dependencies that some of which you probably don't know because one person in your company runs the thing, and trying to figure out everything that's connected to that, you only find out when you turn it off. So everything is connected, everything's constantly changing, and it's getting faster and faster from a development perspective, from a deployment perspective, and from a risk perspective. So because of all this, attackers have more and more options, right? We still have all the traditional IT stuff. We still have your Nessus findings, right? We still have your missing patches, your CVEs. Well, now we have drift between a baseline. Historically, we had that with, hey, I deployed a gold image to my laptops that was fully patched, that was configured, all my GPOs were set up, great. Well, now I've maybe got a Terraform script that deploys out my AWS environment in a single click. That's great. Well, what if it's deploying an insecure configuration? How do we fix that? Do we fix it on AWS? Do we fix it in the Terraform code? Does that introduce other risks? How do we manage that? You have, of course, the things we don't know about, right? The things that you can't protect because you're not aware of them, or you're not aware of those connections. Things like old websites that maybe got migrated 6 or 7 times and they still technically work because they're accessible via an IP, but somebody stopped renewing the domain name years ago. That's still public facing, it's still an attack vector. Fraud domains. These are things that can be used for phishing, right? It's not enough that we keep track of apple.com, but but we have to keep track of the misspellings of apple.com to know how those attacks are coming in, where our users are going to be tricked into clicking, where that then enables a internal access to our environment. And this can be easy to mistype as well. If I'm configuring something and I say, hey, I'm only going to allow access for apple.com, but I mistyped that, I've suddenly potentially opened up an attack vector. Web applications, cloud misconfigurations, you start to get into really specific types of vulnerabilities, types of risks for these different types of technology, right? It's not just about deploying a Windows patch. It's understanding all the nuances of how all those little bits of cloud work together. It's understanding, hey, I have a building management system that controls all the lights, and that's on the same network as everything that controls the badge readers. Well, do I scan that network with Nessus? Last time I did it, all the lights went out. So I stopped doing that, right? Well, if somebody gets on the Wi-Fi and they see, hey, what's this device? Well, that device is the controller for the door locks. That's an attack vector. All of these things have to talk to the internet to get updates. Sometimes there's VPN tunnels back to the vendor for management purposes. Without understanding how all of this is mapped out, how all of it is supposed to work, you run into a lot of challenges with trying to protect it. The last one here I'll touch on is AD, Active Directory, Azure, Entra, whatever you want to call it now, your directory structure. In most environments, the directory structure, whether it's Okta, whether it's Active Directory, whether it's a combination of the two, that's your keys to the kingdom, right? If you, by default, you are allowing a user access to A, B, or C, it doesn't matter that the system's fully patched. It doesn't matter that the system is not exposed to the internet directly. If somebody gets on that machine, they're allowed to log in by design. So do people have the effective permissions? Active Directory has been built out over time over the past 20, 30 years. It's got 4 million different security settings that change all the time, and the behavior of those changes. There are certain settings within Active Directory that will give you domain admin without, and by design, without ever having been in the domain admin group. Are you checking for those? Is it something you're monitoring constantly, or do you have a pen tester come in once every 2 years and say, here's your report on Active Directory? Microsoft recommends, depending on what documentation you read, every 6 months to 2 years. Well, chances are when you get that report, it's going to be exact same things from the report 2 years ago. Maybe different usernames, maybe different accounts. But all of these things work in tandem, right? If I have a machine that has access because it's in a certain OU to talk to server X, and the user on that machine is allowed to talk to server X, that user gets compromised through a phishing email. Well, we're not talking about exploiting CVEs. We're not talking about something that can be fixed with a patch or a configuration update. That's all by design. So the attacker just logs in, grabs all the data, and moves on. Right? These are other security things that we don't normally think about, but as all this stuff gets more and more connected, we need to think about. And traditionally, these have been really siloed, right? Your ad hoc report from Active Directory, maybe from a pen test, maybe from a tool, your Nessus one-off scan, your web app scan with Burp or whatever your tool is. None of this stuff talk to each other. They're all run by different teams. They're all managed from an operational perspective, sometimes from a budget perspective. From the IT side, they all have to talk to each other for everything to work properly. But we don't think about, from a risk perspective, how these vulnerabilities, how these risks interact. So when we talk about defense, where we focus our defense really matters. All right, and there's 3 main areas, right? There's preventative, reactive, and then response and recovery. Something already happened, I have to clean it up and make sure it doesn't happen again. So preventative, security state. What's the state of my system in a given moment, right? If the state of my system is that the firewall is turned on and it's actively configured to block everything, that's the state at this given moment. That is a preventative state. Reactive, that's more event-based, right? I'm going to respond to an event. I'm going to automatically block this IP address because it was initiating attacks against my website. That's event-based, that's reactive. So usually, almost all the attacks, everything comes in and it's your preventive controls first, right? When we talk about, in the generic sense, being more proactive than reactive, preventative controls are what's going to stop most of your stuff. After the attack lands, now you're dealing with event-based. Hey, something happened. Do I have to deal with it? Do I take an automatic action? Do I notify somebody because it's too complicated? Maybe it's allowed. Okay, the attack happened. Now what do we do? All right, do we have to reset passwords? Do we have to patch a bunch of systems? So when we talk about security controls, preventative side, those are configurations, those are patches, those are making sure that stuff is in compliance. Compliance actually does matter, it's not just a checkbox. A lot of the stuff that's hardened in, say, the CIS level 1 benchmarks, if those are done, lots of vulnerabilities won't be exploitable on your systems, even if you're missing a patch. From a vulnerability perspective, we're also talking about things like cross-site scripting for web apps, SQL injection, et cetera. Identifying and fixing those, that stops something from happening. Firewalls are somewhere in between, right? They can alert you, you can block stuff. At the end of the day, you have to allow things with firewalls for the business to function, so they sit somewhere between. Reactive controls, endpoint tools, your SIM, things that will automatically block, that sort of thing, things that will automatically alert. CrowdStrike was talking about some of this stuff this morning. And then how do we recover? Do we restore from backup? Do we trust what happened? Right? Do we do a complete forensic review? Do we update our incident response plan because we figured out our backups don't work or we weren't taking backups? So traditionally, something like attack path analysis has taken place in these last two areas. It's the reactive side and the response and recovery. We see these pretty flow charts where you see from a execution of an attack, phishing to exploiting a CVE to compromising this domain to exfilling data, right? We read all those great blog posts about what happened. We try to apply those things to our environment so they don't happen to us. Great. Well, that's all reactive. That's after the fact. What if we were to apply that to everything? What if we were able to look at everything from a preventive perspective, from a security state perspective, and say, how would an attack look? How could an attacker move? So this attack path analysis, here's an example of that chain. Somebody exploits a vulnerability, they authenticate because they get creds. They either write a file, depending on the exploit, they escalate privilege, and then they move on from there. This takes a lot of work to figure out what exactly happened in an attack, and usually, because all of this is so complicated, it's just one of the many paths that an attacker could have taken to get what they were after. But it's the one we discovered because it's the one that they used. All right, so how do we do this better? I've got Joe, he's got to work from home, laptop. Joe's trying to get phished, right? Because Joe works for an important company and an attacker wants in. Well, Joe's machine is vulnerable because he doesn't have patches, or there's an issue with the patching tool on his machine, or there's simply too many things to patch and we can't do it all in a reasonable amount of time. Pick your poison. There's 1,000 reasons, right? So Joe gets phished. Well, Joe is part of the remote users group. This is by design because Joe works from home. Joe has access to an app. That app has stored credentials, gives access to the domain. Right? Somebody logged into that critical Windows app server once with domain admin to apply a patch to fix something, and those credentials now live there until they're changed. So what happens? All right, I've got two data sets here. I've got missing patches, I've got and configurations, and I've got identity. I've got Joe as a part of this group. Well, because Joe is a part of this group and he's missing patches, what if I could combine those data sets and say, hey, I can now see this attack path before it happens because I know these things, right? I know that there's stored credentials on that box. I know that Joe is a part of this group. I know that Joe's laptop is vulnerable to this thing. Now this gives me, hey, there's a bunch of things here I can fix. Simply by combining two data sets, and I fix one of them, it breaks the attack path, right? I don't have time to fix everything. Everybody's time is important. We don't have time to do all of that. But I can fix one thing, right? It's probably going to be stored credentials, just because that's probably the easiest thing to do. Well, you know that box? There's no multi-factor on the VPN on that box because I haven't had time to set it up, or Joe has an exception because he's an executive or his phone is old and it don't have the budget to upgrade it, or whatever the reason, right? There's an exception there. Let's add in some additional data. Let's add in data from operational technology. Let's add in more data from identity. That box, that domain controller, there's a trust relationship with the same domain that controls my infrastructure, that controls my buildings, right? There's that shared infrastructure. And there's a trust relationship because my domain admins need access to both. And I don't want to maintain multiple accounts. So there's a trust relationship, again, by design. Well, because that trust relationship is there, now that one compromised remote user, that one compromised box, can lead down a path that compromises not only my IT infrastructure, but my OT infrastructure as well. And with this, now I see this is where I need to focus my efforts. This is the item that I fix. This is the item that I spend time on, and it breaks multiple attack paths. This is a smarter way to look at risk because nobody has time to fix all of these things, but I can fix one thing. I can harden that box. I can remove the stored credentials. I can maybe fix that trust relationship. I can do that one thing, and it breaks both attack paths. So we're going to pivot a little bit. We have all of these tools, right? All the data is separate. When we start to combine the tools, we see the benefits of that. Well, all of these tools separate. Each one of these tool sets, whether it's VM, whether it's web, whether it's identity, whether it's reactive endpoint, whether it's your pen test reports, whatever it is, they're massive, massive data sets. And they've got way too much data, right? So when we look at these, we're thinking, hey, how do I measure success? Do I have to fix everything? That's the way most tools are designed today. You have to fix everything. That's the only way you're going to be secure. That's the only way you're going to get a good grade, however that grade is defined. So when we say, hey, I reduced my vulnerable assets by 30%, what does that mean? It probably means something different to everybody. And there's no context here. What's an asset? Is an asset a server in my data center? What does a vulnerable asset mean? Does this mean that I reduced my vulnerabilities from Nessus on my data center boxes by 30%? Does it mean I got rid of 30% of my data center boxes? Right? This is not it's not an effective way to communicate risk. 75,000 vulnerabilities fixed. Great, it's a big number. Anybody remember it wasn't Shodan, but the old map? You see the lines tracing across, showing all your attacks in real time, the world map. Really cool, visualized, great. Everybody wanted that map in their SOC to show, hey, we're blocking all these attacks from all over the world. Great, it's a good visualization. Doesn't tell you much from a risk perspective. 75,000 vulnerabilities. If I've got 1,000 systems that I'm responsible for, that's monthly patching. That's not vulnerability management. I'm deploying my monthly Microsoft patches. So that doesn't tell you anything. Are these low vulnerabilities that don't have exploits that are never going to be fixed or never going to be exploited? Are these critical things that actively were exploited in the wild that other companies in my same industry are being targeted with? You have no way of knowing. We try to be fancy. We try to be smart about this, and this has evolved over time. So we see, hey, my mean time to remediate, MTTR, less than 80 days. Okay, it takes an average time to remediate an issue of 80 days. That's not bad. Usually 0 days are not what gets you. But what does that mean? What's a vulnerability? What's a risk in this sense? Right? Is it a Nessus finding? Is it you've got 40,000 cross-site scripting findings on the same website because there's so many attributes and it's present on every single page and they're all dynamically generated? So you've got 40,000 of them? Well, I made the one code fix and I fixed 40,000 things. I'm done for the month. Is that actually reducing risk? From a compliance perspective, hey, I'm fully compliant. Cool. What does fully compliant mean? Does that mean I submitted all my data? Does that mean I am compliant with all of the settings? What do those settings actually mean? Do they actually reduce the risk that I see in my environment? Now, these are things that we have to live with. We can't change our reporting structures overnight, especially in given verticals now we're seeing more and more cyber insurance that's asking for these sort of metrics. But from an actual risk reduction perspective, to give your teams, hey, I want you to focus on the things that actually introduce risk in your environment, these don't mean a whole lot. So from a context perspective, we don't have context for any of these. We're going to try something. What does this mean to people? Anybody? I'll pick on the Tenable guy. What does this mean? Okay? You've got a 24/7 SOC. Somebody's always looking at stuff. What else does it mean?
It's a computer screen.
Computer screen. Great. It's a physical asset.
Exactly.
Okay. Anybody else? Yeah.
You're actively watching for something that you know is going to need to take action.
Okay. All right. We're looking for the things that we know we're going to have to deal with. Anybody else? All right. So it could be a monitor. Extra credit. Right? It could be a physical asset. If I'm saying I have monitors, okay, do I have people in my SOC? Right? Do I have a bunch of physical things sitting around? Could be a heart monitor. Maybe I work in healthcare. Heart monitors have network cards now. It's terrifying, but they do. And they're likely running Windows. Yeah. Yep. Could be a monitor lizard. Right? Maybe I'm responsible for a zoo. This is a real life example. Could be a school, could be a hall monitor, right? We don't have context for what this means. So when we're talking about how we're communicating things, how we're communicating risk, we have to provide context. These could all be valid from a security perspective, right? Hall monitor, do I have somebody watching what's going on to look for infractions, right? If I'm responsible for an asset inventory, do I know where all of my physical monitors are? Do I think that a physical monitor is just a monitor, or is it an all-in-one computer? Okay? So, thinking about context, thinking about volume-based reporting, just try to get away from it. It can be useful with the right context. But generally speaking, the tools today don't push us in that direction. Or they're so hyper-focused that somebody who's not working in that tool day today has no idea of the sentence that was just uttered. I've closed 40,000 cross-site scripting vulnerabilities that were against this attribute in my dev websites that were hosted on AWS. Okay, that provides a lot of context. But again, how much is that actually reducing risk? Maybe it is, maybe it isn't. So when we talk about how we communicate risk, can everybody understand what we're talking about? Right? When the technical folks communicate this up to the C-level, when the C-level communicates it down of, hey, I need you to fix A, B, and C, can everybody understand what we're talking about? I had a CISO once, back before I went to the dark side and worked for a vendor, who they read an article in SC Magazine or something that talked about a breach with an Oracle database. And his takeaway from that was Oracle gets breached. So it filtered down to me. I was the technical lead. And by the time I got at the end of the game of telephone, the question was, how much Oracle do we have? And how do we get rid of it? My organization at that point had 60,000 people in it. We used Oracle a lot. We used it everywhere. So how much Oracle do I have? That's a subjective question. Are you talking about the databases? Are you talking about any software that Oracle has ever made or acquired? Are you talking about how many computers do I have that have some instance of Oracle on them? How many contractors am I currently employing that work for Oracle? That came up because we had a few. So the context matters. When I look at this from a C-level perspective, right, I'm not as concerned with the nitty-gritty details of, okay, I deployed August's Microsoft patches, great. But where do I need to allocate resources? Is there a particular group that's contributing the most risk? Is there a particular technology? Is there a particular region or sub-org? However you define your internal organization, how can I effectively allocate resources? What remediation and mitigation actually fixes that, right? Is it deploying a patch? Sometimes it is, sometimes it isn't. Is it putting a firewall up? Sometimes it is, sometimes it isn't. Is it making sure that the state of our firewall or the state of our configuration is as it was when it was deployed? Something that attackers often do when they get a foothold in the environment is they start disabling security controls because we're not looking at the active state of a given thing. And file integrity monitoring and configuration monitoring in real time is expensive. There are great tools out there that do it, but they're expensive. So if I'm an attacker, I get in, hey, there's a GPO that turns on the Windows firewall for all desktops. Cool. I'm going to change that GPO and turn all the desktop firewalls off. Are you monitoring the state of your GPOs? So where do we focus remediation? How do we assess that? And where does it have the most impact? And where do we start? If I've got all these tools, hell, if I have one tool, and one tool is reporting I have 1 million critical something, how do I start with that? Do I start with the criticals? We rolled out a new tool, again, pre-vendor life. We rolled out a new tool across the enterprise, and the owner of a relatively small part of the organization, they're charging maybe 100 people, said, hey, this is brand new to me. I need some advice. Where do I start? And me and my naive self, I said, hey, just start with what's labeled critical. And they said, that's great, but there's so many. What do I do? And that was 15 years ago, right? They had 100 people they were responsible for. Their hat was they were the CISO, they were the privacy officer, they were a half-time desktop tech, and they dabbled in procurement because they had 100 people in their org. They didn't have time to go fix 5,000 critical findings. So where do we start? What introduces the most risk? And what are the outliers? Outliers can help you identify broken processes. So if I have an organization that, hey, I did a bunch of scans with tool X, Y, or Z, and all my organizations look great except for this one. Well, why? Do you not have enough licenses with your patching tool to cover that suborg? Were they part of an acquisition that came in and they're still using a different tool? Did they get lost in the churn? Do they not come to your monthly meetings? And do they have any idea what security is? But identifying those outliers can help identify places to focus resources and to focus effort. And that gets back into like unknowns, right? We don't know what we don't know. If we don't know about the outliers, if we don't know about how all these things are interconnected, we can't apply resources effectively to fix them. So, from a takeaway perspective, we need to look at this from a more preventative perspective, right? And I love CrowdStrike. I love endpoint tools. I spend a lot of time there. But a preventative approach, and that's what's going to give CrowdStrike, that's what's going to stop a lot of the alerts. So you can actually look through your endpoint tools and say, hey, this is actually important because it's firing, as opposed to there's 5,000 things firing a day. I don't have time to look at all that. Appropriate preventative tools help reduce the workload down the stream. And you have to do it continuously, wherever possible. Something like cloud, where maybe to scale out a web app because I have a product launch or I have a new initiative that has to go live. Maybe I've built that web app so it automatically scales out to 1,000 containers or 1,000 EC2 instances to handle the load of launch day. Well, am I assessing all of that? Do I have time to assess all that? Does it matter if I assess all that if they're going to be destroyed in a week? Does it actually increase my attack surface? It might not. But we need to account for this as technology develops, as we see more and more interconnections between all of this. When we think about some of the old style approaches to security, like attack paths are great. They tell us what happens so we can pinpoint fixes easier. But if we start to apply new data toward them, like proactive data, like state data, now we can start to identify, hey, this is how I could get from A to Z. And I can do that in an automated fashion. So I can say, hey, this is actually a risk to my environment, and this one asset is the choke point for 30 attack paths. Well, I'm going to spend the 5 minutes I have today when I'm not in meetings to fix that one asset, whatever that asset is. Context is really, really important. If you get a report that says, hey, we fixed 100,000 things, don't assume that you know what those 100,000 things are. Don't assume that that's actually reducing risk in your environment. Right? Mostly, and I'll pick on firewall vendors here, back in the day, it was great metrics to say, hey, we blocked so many attacks. Cool. But if they weren't going to land anyway, because they were against a vulnerability that you didn't have, or they were against Solaris boxes and you don't have Solaris boxes, what's the point? Volume-based metrics, be wary of them. They're really good for workload management, saying, hey, I have X amount of time, I did this thing. But they're not great for how much risk did I actually reduce? Is my security program effective? It's good to know if your patch management tool is effective. Hey, we successfully deployed 50,000 patches out of 51,000. Great. And broadly, this is not news to anybody, but cybersecurity is complex. We can distill it down. We can take all of this data and make useful connections with it and apply that learned information to actually reduce risk. But it's something we have to change when we think about security, when we think about risk. Right? It's easy to put an engineer in a room because the engineer was the one who found the 0 day, the engineer was the one who found the compromise. But you put him in front of the CISO and the CISO says, hey, tell me what happened. We don't, from a technical perspective, and I'll speak for myself and I'll broadly speak for most technical people, we don't do a good job of simply explaining something. We want the details. We feel that everybody else wants the details. Consequently, when we get something really simple down of, hey, I need you to make sure that we're secure, that's not enough details for us to appropriately apply things. So we have to think about what's the context of how we communicate both up and down that chain from a C-level to a technical person to everybody in between. And with the game of telephone, we have to make sure that everybody in the chain understands that. All right. Any questions? Are you too busy eating? I hope somebody saved me a plate. Okay, good. Cool. Thank you very much.
Thank you, Seth. Thank you for the lunch. So